Okay, good morning everybody and welcome to my talk, Building a Web Application with Go. I am Martin Radile, software developer from Cologne, and I work at Alary Solutions. For the last 12 years I mostly did a lot of content management projects on the backend side in Perl. Then I started using Go about 2 years ago for personal side projects, and eventually I began using Go for microservices and command line applications for customer projects. This worked very well, and Go has now become part of our tech stack. So what is this talk about? Last year we developed a web application for a customer, and in this talk I would like to give an overview which Go libraries are used in this project. I will go a little bit into detail which libraries were useful, which were not useful and why, and I will also show some code snippets. The task was to create a car accident reporting tool. Our customer operates a huge car pool for its employees, and from time to time these cars take some damage. The process for reporting a damage was to fill in a paper form and send it back to their back office. This could take several weeks, and the whole process was very error prone. And the goal for the web app was to fully automate the process. The employee is now able to open a web app on his mobile device, fill in the form, take some pictures, hit a button, and the report is sent. We were a team of 5 people, an UX designer, a product owner, product manager, a front-end developer, and me as the back-end developer. The whole team was very excited because we had free choice of technology for back-end and front-end. Although there were some technical requirements, the user had to authenticate himself via SAML 2 to a central IDP provided by the customer. The application had to be usable on a mobile device and on the desktop. The app needed to generate a report with images of the incident attached, and the customer wanted to ingest these reports by email with the images added as attachment. The hosting platform was completely unknown. We didn't know if they would host themselves on-premise or in the cloud, if the operating system was Linux or Windows, or if we could use containers. So what did we choose? Our front-end developer chose to write a single-page application with Vue.js. I'm not going further into detail on that because you're here to hear something about Go. I choose to use Go as the backend language. The main reason for choosing Go was the ability to create a single static binary with all front-end source files embedded. This comes in very handy if you cannot use an automated deployment pipeline and have to deploy the whole application manually. As I mentioned, we did not know what the hosting platform would be, so using Go reduced the risk of dependency management and deployments. Choosing Vue.js, Go, and the listed libraries was a good choice because we finished the project on time, budget, and at the promised level of quality. So this could be the end of the talk, but I will go a bit more into detail. As I don't have time to talk about all these libraries, I will only talk about the most important ones for this project. These are the web framework Echo, the object relational mapper Gorm, SAML 2, and Logrus. Let's start with the most useful library. Contrary to a popular opinion, I did not want to rely on the standard library, and I did not want to code everything by hand. There are quite some web frameworks in Go, like Gin, Bigo, Micro, Buffalo, and more. Some frameworks come with a relatively small set of features, and others, like Buffalo, provide lots of features. Buffalo seemed a good choice in the beginning, but I thought it was too much and forces me to architect my application the way Buffalo specifies. I choose Echo because it has all the features I needed and gave me the right amount of freedom to architect my application as I wanted. Echo is a web framework that helps creating web and REST applications. Lets you define routing definitions, assign them to your handlers, and inject middlewares in a very few lines of code. Echo comes with a lot of predefined middlewares, but also defines a middleware type, so you can implement your own. To start a new Echo server, you have to instantiate a new Echo instance, define a path, and register a handler for an HTTP method. If you want to create a REST application, your root definitions could look like this example. Not much code and easy to read and understand. Echo comes with helper functions for marshalling and unmarshalling JSON objects. The bind function receives a pointer to a 0 value struct and unmarshals the request body into it. The JSON function below does the opposite, marshals the struct to a JSON representation and sends it as the response body. Of course, this is not a real-world example, it just echoes the input. Echo was easy to learn and has excellent documentation. It was fun to use and felt like it wasn't in the way. Gorm is an object relational mapper for Go, and as I know, the most popular one based on GitHub stars. It lets you define your database structure by using structs and annotating them with tags. Gorm has support for multiple databases, simple migrations, and a mechanism to implement hooks for create, read, update, and delete events. You don't need to write SQL, but you can, as the underlying database handle is accessible. What we have here are two structs that have a relation. A role belongs to a person. By adding the fields person ID and person to the role struct, you tell Gorm that these structs have a relation. In this case, a role belongs to a person. On the right side, Gorm opens a new database connection handle, and by executing the auto-migrate functions, all tables are populated to the database if they don't exist or updated if needed. In the next statement, we create a nested instance of our structs and tell Gorm to save them to the database. Gorm creates two new rows, one for the role and one for the person, and takes care of adding person ID to the role entry as a foreign key. Unfortunately, the documentation is, especially for beginners, not very clear. Gorm is very good for quick prototyping, but in the end it felt more like dealing with the Gorm way of doing things than focusing on the business logic. For new projects, I would probably use SQLX. This would result in more boilerplate code, but also more control. Go SAML 2 is the only implementation for the SAML 2 protocol I found. It supports a couple of identity providers out of the box, and I managed to make it work with Keycloak in my development setup. Go SAML supports request signing and encrypting, but unfortunately I was not able to make the request signing and encrypting work with the customer's identity provider. There were problems with too big requests and base64 encoding, and we could not find out if it was the reverse proxy, the identity provider, or the SAML 2 library. So this is still a future task for me to find out what was going wrong. I'm not showing any code snippets because it would be mostly configuration here. In the end, Go SAML 2 does the job if you can live without request signing and encrypting in some certain cases. Logras is a structured logging library. Structured means that it not only prints one big line of text, but instead you are able to use separate fields for your logging messages. This feature makes most sense if you use a JSON formatter and feed your logs to a log aggregator like Splunk or Elasticsearch. Logras is a drop-in replacement for the standard logging library. Just change your import path and Logras works. The most common configuration options are setting another formatter and the desired log level. This configuration, for example, keeps the output of the info level and makes Logras print JSON messages, as you see below. Logras has the type log fields. That is a map of string interface map of string interface type that you can feed with key value pairs. Each key value pair is individually printed in the log message. I'm not showing here the JSON output because this is more human readable. A very useful feature are default fields. You can create a new log entry instance and set some default fields. When using this instance, the default fields are always printed, so that you don't have to repeat it yourself. Of course, you can extend the logger with other fields if you want to. Logros is easy to learn, has a very good documentation and all that's needed for a good logging library. So in the end, Echo did help a lot and was fun to use. It was easy to implement the REST functionality and plug in the SAML 2 authentication and extend with other functionality through middlewares. Gorm helped at the beginning to create a minimal viable product, but backfired later when requirements got complicated. For the next project, I'm probably going to use SQLX and do more by hand. Go SAML 2 worked, but if I have the choice, I would use something else like OAuth 2 or OpenID. Logros was very useful, provided a good feature set, and was fun to use. Go as the backend language was also a good choice. The customer asked us in the end to host the application on AWS. So for deployment, we simply created an Elastic Beanstalk environment and could deploy the application with only a few changes. Thanks.